Good morning, good afternoon, good evening, everyone. It's great to have you here for our next virtual Genomics in Health Implementation Forum. And just before we get started, we'll run through a few of the housekeeping for this meeting. So Lindsay, over to you.
Thanks, Catherine. All right, hi everyone. So I'm just going to really quickly explain how to use Slido if you haven't used it before. So we'll be using Slido to help moderate questions and generate discussion, and we have a couple of interactive polls for everyone today. So if you haven't used Slido before, you can navigate to slide.do in your web browser. I will also put a link just in the chat there that will also take you to the same event. So once you're there, you can enter the code hashtag GIF 2022. And then when the questions are launched, you'll be able to interact with them either through your web browser or the app if you have it on your phone. So we'll wait just a minute for everyone to get to the right place. And then we've got two just introductory questions to make sure everyone's got it working properly. Catherine, do you want to click to the next slide, please? We'll launch the poll. So we're asking, where are you joining us from? Which country or town, city? So hopefully when you navigate to the app or to the website, you should see this poll pop up for you. There we go. Berkeley, Cambridge, UK. Lots of US, Canada I'm seeing so far, Australia. Overwhelmingly from Cambridge, UK. Let's see, Italy, fantastic, welcome. Seeing Toronto, Montreal. Still mostly Cambridge, a lot from Toronto. That's fantastic.
Boston's gaining.
We're coming up. Boston's gaining. What else do I see here? New York, Boston, Singapore. Fantastic. Welcome. All right. So I see 38 responses in. So I think everyone's getting the hang of it. Do you want to click to the next slide for me, please? We'll try the next question here. So just which organization or initiative are you representing? And same thing, if you navigate to Slido, you can just type it in and it'll appear on the screen here. Genomics England, Utah, Berkeley. Lots of Australian genomics. Genomics England, GA4GHers. Baby-seq, yeah, this is fantastic. Lots of different representation.
Yeah, Australian genomics.
Taking the lead so far. All right, so I'm seeing 42 in, so it looks like everyone, so if you're just joining, again, I'll repost the link just in the chat here. So we are using Slido, and these are just tester questions to make sure everyone's got the hang of it for the rest of the meeting. Okay. I think that's good. We got about, yeah, more than half of attendees have responded, so that's fantastic. So Catherine, I will hand it back to you.
Thanks, Lindsay. So let me just give a few introductory background comments on the Genomics and Health Implementation Forum. And we're really the implementation arm of the Global Alliance for Genomics and Health, where we look at how we apply the standards that are developed across data sharing, regulatory and ethics and data security in terms of implementation into research and into healthcare. So what we've found is that by bringing together all the major initiatives in genomics across the world, it's a great forum in which to share our collective learning about best practices, challenges that we're facing, to identify areas of collaboration and sharing of resources and expertise, but also to advance projects and pilot projects around global data sharing. And really, we've identified that newborn screening is something that we're all starting to think about in our countries around the world. And it seemed like a great opportunity early in the piece to share our experiences, to look at what we also can do from the Global Alliance perspective to assist in that and make sure that we can do that at a global scale. So the focus of the Global Alliance is around setting standards and developing tools and implementing them around all of this cycle, from the consenting of the patient or the data donor, collecting that information, the sequencing, how we store that, how we analyze that, and then how we make it available and reanalyze it for either research or for clinical care. We have a setup in the Global Alliance where on one side, on the left side of the screen, we have around the world an amazing network of expertise in bioinformatics and regulatory and ethics in data security that are all working together to create these international standards. But then on the other side, we have an amazing community of people that are implementing and using genomic data in a research setting or in a clinical setting across rare disease, cancer, basic biology research, looking at complex diseases. And these are part of our real-world driver projects, as well as national initiatives. So we started out really as a collection shared by Mark Caulfield and myself of bringing together different countries. But we really realised how important this community was in terms of implementing standards so that we can achieve the dream that if you're looking at a particular gene or a particular variant, you should soon be able to source from around the world what is known and what the evidence base is for interpreting those variants. So we also need to make sure that the standards fit the needs across multiple different healthcare systems. We really want diverse output so that we're a truly global organisation. We found that it needs to be scalable as there are so many countries around the world that are working together, but how do we take that to scale? And then how do we relay back to our work streams within Global Alliance what the needs are of our genomics, clinical and research community? And so here today we have representatives from all ends of the spectrum to tackle this question around newborn screening. This is a little bit of the history. We've been meeting together now for over 8 years. And of course, as with everything during COVID, we've had a number of great workshops and virtual meetings over the last couple of years. But I must say, we're really looking forward to getting together at our Global Alliance plenary in September in Barcelona. And I'm so looking forward to seeing everyone in person. Our current GIF members are shown here. I think we're getting close to 30 members, and membership it's very easy to join GIF. There's just a simple form that we can also put the link within the chat in case you're not already a member. But membership has its benefits. We circulate monthly newsletters where we really highlight and focus on different areas of work that we're doing, but also spotlight and introduce you to different members of the community. So you can subscribe via that link below to that newsletter. But now let me come to the purpose and the focus of today's workshop. And this arose as our steering committee in GIF was talking about how we're all starting to think about and to implement pilot projects around newborn screening. And really, this is the big step. We've been focused so much, for example, on rare disease and cancer to date, as they're the areas where we can most rapidly translate and use genomics knowledge within the clinical space. Throughout the world, we all have different approaches to newborn screening, usually via the heel prick test, using mass spectroscopy to screen for 25, 30, sometimes more different disorders, where it's very beneficial to know about them early so that we can intervene early and have preventative measures. So what we're looking at now is how we can move from, say, looking at 25 different disorders to multiple time bombs that might be ticking, where to know about these disorders early, it's useful for children and for their families, but really with a goal on how this is eventually going to move into taking genomics to a population scale. And of course, taking genomics to scale in this way will have its challenges. We also see that newborn screening is an entry point along with reproductive carrier screening into be able to use genomic information in a whole of life way. We're very familiar with its applications around reproductive carrier screening, around the applications in child health and rare disease and in cancer. But we also are increasingly aware of its value in prediction, for example, in use of pharmacogenomics, but also looking at polygenic scores to predict the risk of complex disease. And so really this workshop I see as a way of bringing together the collective expertise around the world in terms of what is happening, but to then look at where this might go and how we can work together to really accelerate our work in this area. So there are a number of challenges, and today we're going to talk about practical approaches, but then what also are the challenges that we need to solve around the potential for newborn screening done at genomic scale. We need to look at what's being done in different countries around the world and different approaches, which conditions that are appropriate to include in the interpretation of a genomic newborn screening. How do you report results? What does it mean for the workforce? Consent, when, who, how? The data, we're going to be generating so much data. How do we store it? How long for? How do we reuse that data? And what are the security and the regulatory and ethical implications of that? And then really the bottom line in this from the Global Alliance perspective is how we as at the Global Alliance can contribute to the standards and the tools that are really going to facilitate this practice internationally. So we're going to move now on to the agenda, and just to walk you through, we're going to get some overviews of initiatives that are in progress or are planned across England, Australian Genomics, Screen for Care, BabySeq, and then we will have a panel discussion, and Lindsay's already taken you through how we'll use Slido to do that. We're then, from the Global Alliance perspective, going to look at some of the issues that we need to address around regulatory ethics and technical standards. And I see this as a beginning of a discussion that we will take forward, that will bring into the Global Alliance, into our work streams, and then feed back into this community. So this will really be an iterative process, and I see that this will be the first workshop of many in this area as we're working together to harmonise approaches internationally. So we encourage you to participate. Slido, Lindsay's already taken you through. You can continue discussions using chat. I think that raising hands with the number of people we have on this call might be a little beyond us, so do use Slido. And so now I'm going to find out how I uncontrol the screen, so please take it back. That's excellent. And then I will now introduce Dr. Richard Scott, who will be talking about the Genomics England Newborn Sequencing Program. So over to you, Richard.
Thank you. Thanks, Catherine. And I'm really pleased to be here this evening to talk about our work, but mainly to listen to everyone else about their programs, but also crucially views on where GA4GH can help us as we think through, as Catherine's laid out, there's sort of many issues ahead of us as we explore the best ways to look at the value of whole genome sequencing in newborns. Let me just make sure, I think I'm controlling slides now. So I'm Richard Scott, I'm the Chief Medical Officer at Genomics England, and I'm a clinical geneticist by background. I also work at Great Ormond Street Children's Hospital. We've been thinking about the potential of whole genome sequencing in newborns for a few years now. We've been doing some background work within the UK, jointly with our National Screening Committee and with various experts and patient groups. And we're very fortunate to have had the backing from our government to launch what we're calling our Newborn Genomes program. We've had funding for the last year really to focus on public engagement and exploration with experts, and just to begin to design what a program might look like to explore this. And what I want to do is share with you where we are today, which is still very much in a design phase, and also where we are in terms of the way we're addressing the different questions that are ahead of us, and the different aspects of the program, particularly with a sort of lens of the sorts of questions that I think GA4GH will particularly help us work through. So we very much see this at the moment as a research question. We're really excited about the potential value of this. As Catherine said, as we'll hear from others, there's enormous potential value in identifying severe treatable childhood conditions early in that window of opportunity where we can make a difference before it's too late. We also know this is complex, and we see this our program as an important part of answering research questions, which can let us understand what the benefits are, what the challenges, the practicalities, so that we can help others make decisions about whether this is something that should be adopted in the longer term. And what we've developed a vision for, based on work we've done with the public in the UK, crucially, we've formed an NHS steering group with input from across medical specialties and genomics and screening expertise in the UK to design, to look at what the questions are we feel we need to address. There's real consensus around the fact that this needs to be done in the context of an ethics approved research pilot, that to really learn what we need to, this needs to be embedded in everyday healthcare, so in our National Health Service. And we think there are 3 distinct areas for exploration. They're overlapping with one another, but they're distinct, and they're important to hold separate in one's mind as we explore the value in these different areas. So the first one is that one around identifying childhood conditions early, seeing what value whole genome sequencing can provide with today's knowledge alongside the existing newborn screening, the heel prick, done in various ways, but also the other aspects of newborn screening in the UK, for example, including hearing testing, etc. Secondly, around how we can enable research, so we're not just reliant on today's knowledge, the conditions we can diagnose today, the conditions we can treat today, but also so we can think about how we generate evidence so that tomorrow's newborns can access treatments that today aren't available. And then thirdly, there's that question around the potential of genomic data being useful over the lifetime, or at least for a more prolonged period than just during the newborn period when it's used for that specific screening setup, or in the context of that second question, for specific research questions. And those questions we're going to explore sort of together alongside one another in this NHS embedded context, so that we learn not just about the science, about the positive predictive value in the context of newborn screening of particular analytical techniques, but also about the real life impact on workforce and training, and the expectations both of clinical teams talking to families about this, but also the experience of families receiving that in everyday healthcare. And so, as I say, we're at this design phase of the programme. We expect to launch our programme, which will sequence 100,000 babies over approximately a 2-year period, starting next summer. So we're spending this next year in that design, thinking about all of the different aspects of the programme. And the outputs from our programme will be obviously some benefits returned to families during the course of the programme itself, but crucially it'll be evidence to inform decision makers in the UK and hopefully elsewhere around the value of this in their health system. So I think that focus on the types of evidence that we need to generate is really crucial. And I think it's that weaving together of engagement with the public, with experts, Often, I think people consider those as separate conversations. I think one of the real challenges in work like this is to make sure that we have that dialogue in a more sort of joined up way, if you like, because there are very strong public views and expectations in certain areas where we can only really address them by joining those conversations up. We're keen from the outset of this program to design this with the public, with experts, and with the people who'll be delivering it on the ground in the NHS. So this slide here just highlights, and I'll just walk you through some of the questions that we're exploring at the moment. These are the sort of different work streams we've got running within our program. And the little yellow stars, the stars on the different blocks there, show you where there is we've set up already a specific working group looking at some of the questions. One of the really key things is maintaining dialogue between the different areas, because a lot of these questions overlap. So, for example, we have a group going through a process of identifying at the moment the principles that should lie behind our selection of which conditions we should screen for. There are obviously criteria that are out there for screening, currently used by our screening committee, used elsewhere in the world. We're really keen to make sure that we look at those in the context of whole genome sequencing and produce something where we can explain to families and to experts why specific conditions did or didn't make it onto the list for our research program. And make sure that part of that is also about the practicalities. Have we got sort of fully joined up care available in our health systems, so that when we're returning findings to families, we know what the clinical pathway is end to end, and that we see as almost as important as sort of any other aspect of the program. We've also, for example, linked to that, got an specific ethics working group thinking about the ethical principles, not just about the conditions we select, also about the governance of our program overall. One of the aspects that we think will be really crucial during this program is not just setting up the sort of ethical framework, but ethics research running through the program. For example, and we think particularly around the aspect to do with lifelong or longer term storage of genomic data. I think lots of this will be building on existing principles that are there already in genomics or elsewhere in healthcare. But equally, I think there are also some questions that we will be needing to explore where there aren't yet norms. And I think
1 minute warning.
Establishing those and having a to and fro between the ethics work and the ongoing sort of public dialogue during the program will be really important. And then my final slide, just back to this sort of framing slide that sets out how we're thinking about the program as a whole. I think I'd highlight just a handful of the areas where we're sort of thinking about sort of live questions. There are many questions across the whole program. I think just to pick one more, talking again about that longer term storage of genomic data. I think Catherine touched on it before, and I think GA4GH will be useful here as well. I think really thinking carefully about how people expect their data to be held, and access to that data being governed, and the communication about how their data might be accessed will be particularly key in this program in a way that perhaps it's a little different in a diagnostic setting. So Augusto from Genomics England is also going to share some thoughts on the role of GA4GH in this area later, but I hope that's given you a bit of a feeling for how we're approaching our work.
Great, thanks so much, Richard. And we're going to have 4 presentations and then move into a panel discussion. So next cab off the rank is Zenitza Stark from Australian Genomics. Over to you, Zenitza.
Thank you, Catherine. Oops. Let's see if I can work out how to advance my slides. Here we go. So a little bit of background on newborn screening in Australia. So currently we have a number of state-based programs which screen for well over 20 conditions. The exact conditions vary from state to state. So here in Victoria, over the past few years, we have transitioned from implied consent, for example, to specific consent being provided for newborn screening. And we store the newborn cards indefinitely, but there's variability around the country in all of those areas. What we're excited about is a new funding opportunity from our government, which was announced last year. So $12 million worth of research funding administered through the Medical Research Fund, specifically the Genomics Health Futures mission. This will fund a minimum of 4 projects. So these were announced so this opportunity was announced last year. The applications are in and we're going to find out the outcomes hopefully in June. So we expect to see 4 or 5 projects up to $3 million each to run over the next 5 years. We have done a number of studies previously that will inform our approach to designing genomic newborn screening pilots. First and foremost, the Mackenzie's Mission Reproductive Carrier Screening Program, which has actually just finished recruitment. So this was a national program that has offered screening to almost 9,000 couples from around the country. So this was reproductive carrier screening to couples who are either contemplating pregnancy or already pregnant. So this program has actually laid a lot of the groundwork for future population screening programs by developing tools and processes. So for example, most of the provision of information and recruitment and consent were done using an online decision support tool, where genetic counsel is being reserved for couples who have additional questions and certainly for those who received positive results. On the laboratory side, being involved with this program has allowed us to work out a lot about what an analysis pipeline and what the reporting thresholds might look like in order to be able to return screening results at scale. Another key study in this area for us has been the Baby Beyond study, which was run in 2016-17 and was funded by the Melbourne Genomics Health Alliance. So this study offered exome sequencing to a cohort of babies who were found to have congenital deafness as part of newborn screening. But in addition to offering parents testing to identify the cause of the deafness, parents were offered screening for childhood onset conditions. And they were given 2 choices. One of them was to receive results about childhood onset conditions that are treatable, and the second choice was to receive results about both treatable and untreatable childhood onset conditions. And it was very interesting to see that there was actually an almost even split in terms of parental choice, with slightly more parents choosing to receive information about treatable and untreatable conditions, which is not necessarily what I would have thought going into this. Now we've taken what we've learned from the Baby Beyond study and expanded that nationally through the acute care genomics program. So this is a program that offers ultra-rapid genomic sequencing to critically ill babies and children with suspected rare conditions. But 3 to 6 months after that initial result, we're actually offering families a number of additional analyses on their data. And for their children, we're offering screening for pediatric conditions. So for this cohort, we decided just to offer treatable and untreatable conditions. With both of those cohorts, we're conducting interviews with the families to try and gauge their views on genomic newborn screening and how that should be offered in the future. And one question that we've been keen to ask is, when should consent be obtained? And there's been a very strong feeling from these families who have been through these pilots that information about genomic newborn screening and consent potentially as well should be obtained during pregnancy, as the newborn period, there's just too much going on to be able to handle large amounts of complex information. Something else that a few other things that we've learned from the acute care genomics program or testing of sick newborns is obviously how to do it really quickly to be able to deliver results in real time. But also the time is of the essence, and we've had many wins in terms of identifying treatable conditions in this cohort, but also a number of families that have really stayed with us and made us question whether we should be doing things differently and testing for these conditions well before symptom onset. And I just wanted to share this family story with you, and it's one of the families that has really stayed with us and made us want to approach newborn screening. So this was a 9-month-old little girl who was rushed to hospital by ambulance with a depressed conscious state and a rapidly evolving widespread purpuric rash. She was admitted to the pediatric intensive care unit and appropriately treated for meningococcal septicemia. There were lots and lots of clever doctors involved in her care who realized she was running an atypical course, and by day 5 of her admission, she was already enrolled in a program, and genomic testing was initiated. We had a result for this family on day 8, which identified a treatable metabolic condition, but unfortunately she died despite maximal treatment. So often there's perhaps a tendency to come up with 100 reasons why genomic newborn screening is going to be difficult, but it's important to, I guess, keep foremost in our minds why we want to do this, and that is to alter some of these long-term outcomes of treatable rare conditions. So as I said, the applications are in. We're waiting for the results in June. There will be multiple projects funded in Australia, and I just wanted to put an example of one of the grant proposals that has gone in from the Victorian Clinical Genetic Services and the Murdoch Children's, which is where I work, and that's to examine the feasibility and acceptability of a genomic newborn screening program here in Victoria. Based on those prior experiences, we've decided, if we're funded, to offer information about genomic newborn screening and seek consent from couples during the pregnancy using an online decision support tool. We are looking to sequence around 1,000 newborns using whole genome sequencing on the GA4GH cards, which we receive as we're the providers of the traditional newborn screening program in Victoria. So we're not looking to obtain additional samples. We're planning to analyze the data and report on around 500 treatable childhood onset disorders, looking at a turnaround time of about 2 to 3 weeks. And we are very keen to explore this idea of long-term storage and reanalysis for lifetime healthcare benefit. There will be multiple projects funded around Australia, and we hope all of those will come together to form a consortium over the next 5 years to enable collective learning and also help us to develop a national approach going forwards. So what are some of the ethical and data management issues that we are thinking about as we're about to go into these projects? Obviously, I talked a little bit about our desire to improve outcomes for rare disease. There is obviously also concern about not reducing the uptake of the existing newborn screening program, which for us is well above 99%. There's the very important issue of consent, of how and when and by whom that should be provided. And obviously, if we're going to store the data, at what point do we need to reconsent the individuals who are tested as they approach adulthood? Obviously, equity and equity of access is going to be an important issue, particularly for culturally and linguistically diverse groups. And also the issue of distributive justice. Is this a good use of the research dollar? Yes, absolutely. Now is the right time to be running these pilots. Is it going to be good use of the healthcare dollar? Well, that's what we're here to find out and generate the evidence for. In terms of data management issues, obviously an important one is going to be linkage with the electronic medical records, particularly if we are going to enable the reuse of the data for lifetime healthcare, in particularly in offering, for example, pharmacogenomics or screening for adult onset conditions or reproductive carrier screening down the track. Obviously, we want to enable the use of this data for research with appropriate consent, and because we're a federated nation, federating our data is also going to be an important challenge for us.
Great, thanks so much, Sunitsa. And we'll now move on to Alexandra Fellini from Italy on the Screen for Care. So over to you, Alexandra.
Thank you, Catherine. Thank you. Hello, everybody. I'm Alessandra Ferlini. I'm from Italy. I'm a medical geneticist. And I will present our very recently granted project from EU and IMI, which is Screen4Care. You see here the title, so shortening the path to rare diseases diagnosis using newborn screening and also digital technology. So our project is based on two main pillars. So of course, genetic newborn screening that we are discussing now at this meeting, but also digital technologies supporting data collection and data analysis from rare diseases and from rare disease patients. The project has just started, so October 2021, and is now running. And I go ahead. We in the project, this is just to show you the overview, the vision that the Screen4Care has, and is composed by three main pillars, as I said before. So, of course, the newborn screening, so to champion a sustainable genetic newborn screening framework for many rare diseases. Also to federate the ecosystem of rare diseases, the newborn screening knowledge in a single federated repository, and improve and accuracy the speed and to accelerate the patient diagnosis using innovative tools able to better address patients and families and in general rare disease stakeholders toward a correct diagnostic path. Okay, so going ahead, we have many deliverables, many milestones, but just I underline the main milestone we aim at of course achieved. So the first, of course, is the landscape analysis of what is already existing about rare disease, all recommendation, strategical initiatives, and so a sort of general systematic analysis of what is already there. And this is why it's so important that we, as Screen4Care, are interacting with all other initiatives, not only in Europe, but around the world. So this is, of course, why I'm so happy to be here with you now, in order to really be being synergistic and not, duplicate any efforts or any strategies or plan for newborn screening. We have a real life newborn screening running, so on babies, and we plan to run that based on gene panels, but also whole genome sequencing, mainly addressing early symptomatic infants. So we will see that in a while, and also developing new algorithm to screen electronic health records, and this new tool, so symptom checker, in order, as I said before, to provide a ready-to-use, the easy-handling tool to patients, families, and stakeholders to follow up, to monitor the diagnostic path for rare disease patients. We hope to impact on rare disease diagnosis, therefore, in many ways. So at birth, based on our newborn screening approach, but not only as goal of Screen4Care, also in early onset stage, based on whole genome sequencing approach, but also based on our electronic health records analysis, a new algorithm to extrapolate from this data the phenomics related to rare diseases. And finally, generally, the health care providers cycling, so this digital tool that can prime up, to better address the rare disease diagnostic pipelines in order to reduce the turnaround timing for getting the right diagnosis for rare disease patients. So, and also all these approaches, these three different approaches may impact and may also, help in establishing other collaboration and synergic initiatives with similar other projects ongoing. It is important to underline, just checking the time, that we have Eurordis as a partner in the Screen4Care. This is very important for us. Eurordis is directly involved in the scientific aspects of the Screen4Care, not only as a voice of patients, so of course advising and collecting patient perspectives related to newborn screening approaches, but also contributing in terms of research input in designing our genetic panel, especially in the concept of actionable rare disease, which is a very novel way to see rare diseases, but also a little bit questionable. So it is very relevant for us to work together with rare disease patients in order to define really which are the prioritized somehow actionable diseases to be studies to be addressed by newborn screening. And the next, I will go very quickly through these last slides just to show how our project is articulated in different work packages. 5 different work packages, so scientific work packages and 1 dissemination work package, and getting to detail, but not just avoiding to lose too much time, and underlining that work package 1 is based on all ethical issues related to newborn screening, legal aspects, data readiness, and also stakeholder engagement. And work package 2 is the one building up the federated metadata repository to collect all rare disease data and try to get a comprehensive ecosystem, including all newborn screening and accelerated diagnosis related aspects. But staying on work package 3, which is the newborn screening itself, we plan to screen 18,000 infants across Europe. The sites will be in Germany, Italy, and Czech Republic. We will also evaluate all aspects related to newborn screening, the ethical aspects through our ethical board. We evaluate costs of newborn screening based on different approaches, for example, gene panel, or even whole genome sequencing, cost effectiveness of newborn screening versus rare disease early diagnosis. And obviously, the task number 4 is definitely very interesting, and with many aspects we can share with other initiatives. So the whole genome sequence approach, but performed, so carry out in early symptomatic infants. So I don't want to, just underline, of course, work package 5, based on digital tool development and the symptom checker that should be, perhaps, hopefully, be, a very easy handling tool to be available for patients and stakeholders. And of course, the dissemination, this is also a very important task because it's a sort of, basket, including the various aspects of the Screen4Care, also the various boards we have in order to advise and monitor the Screen4Care progresses. And that's my last slides, summarizing our structure. So our ethical, legal, and safety team board, the communication dissemination group, of course, patients advisory board, which is chaired by Eurordis, and all our work packages will feed in terms of research output the Screen4Care. And the next is my last slide. So that's myself and with Nicola Garnier from Pfizer. You know that Screen4Care, so EU IMI projects are co-funded by European Union and FPA partners, so pharma companies, a partnership in Europe. So myself and Nicola are co-lead of this project, and we will carry on the Screen4Care together. We just started. You can see our website here, and this is the final. Whoops, sorry about. And this is the final slide with the acknowledgement. with the full list of partners, 35 partners, both academics and industries which are involved in our project. Thank you very much.
Great, thanks so much, Alessandra. And we'll now move to the last of our speakers in this session, Robert Greene, who's going to talk about BabySeq and his experience to date. Over to you, Robert.
Thank you very much, and thanks for the invitation to speak here. We are a shop that does implementation science and have been doing so around genomics since about 2000, when we first gave back single variants, then graduated to larger panels, then to whole genome sequencing in adults. Along the way, we got involved in designing the secondary findings, return of results for the American College of Medical Genetics and Genomics in 2013. And our history with newborn sequencing dates back to about 2012, where we had been thinking about this as the logical extension of our screening work with adults for obvious reasons. And at that point, to our delight, the NIH, NHGRI, and NICHD put out an RFA for newborn sequencing proposals. And we were fortunate to win one of those and be the only one of those that offered comprehensive sequencing to ostensibly healthy newborn babies. And that's how BabySeq was born. In fact, it was that Time magazine that you showed, Catherine, at the beginning, by Bonnie Rockman, was actually the first public report of our interest in 2013 in sequencing newborn babies. BabySeq has taught us a lot. Let's see if I can click on. It's many people, many more than these have been part of it. So I'm representing a large group of collaborators. Specifically want to call out MPIs Alan Beggs and Ingrid Holm for BabySeq 1 and 2 respectively, and new young faculty, Nina Gold, Nidhi Shah, and Anna Lewis, are doing great work with us on this project. But what's really exciting that I can present to you today is a little bit of real data. And as we think about the real data, obviously we're all interested in the risks, the benefits, and the costs of this technology. And as has been alluded to, screening is very different than diagnostics. But as you'll see from our data, there is a way in which screening segues back into diagnostics in a really fascinating way. So the way we set up our trial was as a randomized clinical trial. And this is, of course, because the kind of people who volunteer for such information are themselves different from historical controls. And this allows us to really parse out some of the medical, behavioral, and economic outcomes in a very rigorous way. And we were able to recruit about 300 families into BabySeq 1. Our very first issues had to do with which genes to report. And with a talented team from the Mass General Brigham Laboratory for Molecular Medicine, we were able to pare down about 1,000 genes. And these were genes that were leaning toward actionability, but not all conventionally actionable. We're really selected for genes with strong and definitive evidence of disease gene validity, because we figured that scientific truth was the most important value here. We also leaned into genes that had, as best we could tell, higher penetrance and, of course, pediatric or adult or adolescent onset. We did end up including a limited number of adult onset genes for reasons that we've published on and I can talk about later. And that turned out to be really fortuitous, I think, in terms of the interest. Now, importantly, because this is often mentioned, we did not decide to return variants of uncertain significance, but only pathogenic and likely pathogenic variants. And I think this is obviously because you want to enrich for prior probability, and you want to try to get as few so-called false positives as possible. Now, it's very interesting that way back in about 2012, we were asking parents on the newborn ward do you want this kind of sequencing for your new baby? And the vast majority were interested. But when we got down to the 14-page consent form with all sorts of horrible outcomes, issues about privacy and discrimination, and not to mention the fact that we're going to randomize you and put half of you into an arm where you're not going to get any results whatsoever, the enthusiasm was not quite as high. Not to mention that many people, after they've just had a baby, do not actually want to talk to anybody about research. So this is a little misleading, because only 10% of people really said, yes, come on in the room, I'm interested in research. This has been misinterpreted in the media as suggesting that parents don't want this service. And I think that's incorrect. They very much do, and multiple other polls, including the UK Engagement Project, has suggested that. When we did get into the room and talk to them, turns out that about 2/3 of them actually enrolled. So that was a pretty good output. The real surprise in BabySeq-1 was that of the nearly 160 babies that were fully sequenced, 11% had an unanticipated monogenic disease risk. And what was even more surprising was that 1/4 of them, when we circled back and examined the baby in light of the DNA finding, they actually had features of the condition that had not been previously suspected. So for example, that elastin mutation you see on the 3rd line, this can be associated with supravalvular aortic stenosis. That particular baby was absolutely normal heart sounds, no family history, but an echocardiogram in follow-up to this finding did find a narrowed aorta, abnormally narrowed aorta. Now you could say that's a glass half full, glass half empty. Maybe nothing will ever happen about it. But if that baby were to go out on the playground and have a fainting spell, I think this would be a very valuable piece of information to know about. And that's how I'm thinking about so much of this as risk stratification, not as diagnosis. We followed all these babies into their downstream medical consequences, and I won't belabor this. We have a really interesting paper that's up on medRx, a preprint server, if you're interested. But what is extraordinary is how many family outcomes were changed as a result of the baby's discovery of the mutation. We tried to start creating a taxonomy of this using the Clingan actionability criteria as a starting point. You can see we're playing around here with shapes that might connote the degree of tolerability, disease severity, disease penetrance, and efficacy of intervention. I don't think any of these graphics are really satisfying yet. They don't really shortcut the kind of dialogue we need to have with parents in order to help them understand some of the pros and cons. But it's fascinating to try to think, how can we take these multiple dimensions and create a meaningful and recognizable taxonomy of what it means to screen for different conditions with different kinds of treatability. Obviously, a major question is the economic outcomes, and we're able to show that in the first 6 months after disclosure, those babies who were sequenced did spend more on their health care. Of course, that's not really a surprise. What remains to be seen, and what we're trying to answer with long-term follow-up, is the value gained, the discoveries, the mitigation of illness, the security that parents feel in light of symptomatology that emerges. Is all of that a value that is worth the extra cost that will come from sequencing, interpretation, and medical follow-up? We did publish one paper that models simply the cost effectiveness of screening in the pediatric time period for cancers alone. And as the cost of genomic sequencing and interpretation is coming down, this is approaching that magic $70,000 to $100,000 per life year QALY. So, I think this is truly within reach. And by collecting empirical data of this nature, we can start to justify it and lay the groundwork for these larger scale. And importantly, we and others are pushing back on some of the narratives that have obstructed progress in this and related fields. The narrative of catastrophic psychological distress, for example. simply is not true in many of the adult studies we've done and does not appear to be true here. We never want to be cavalier about the possibility that we give someone bad news or ambiguous news. But on the other hand, the notion that simply telling someone about a mutation that creates some risk stratification of that baby is going to push them into a depression, anxiety, disruption of parent-child relationship, empirically is not supported by our data. So this is a really exciting moment. This workshop, this gathering of minds and opinions and plans. We ourselves are moving from BabySeq 1 to recent funding by the NCATS Institute at NIH for BabySeq 2, where we're enrolling at least 500 babies from diverse backgrounds, and we have additional volunteer sites in the US that may allow us to move that up above 1,000. But importantly for this community, we're so excited to be talking to the other groups today and to those of you who are listening to this so that we can start to harmonize our interventions, our outcomes, and our resources in order to pool and share the kind of data that's going to truly give us insight into not whether we do this, because we all know it's coming, but how we do this properly, effectively, and humanely for the benefit of all humans. So I'm really delighted to have had the chance to speak to you a little bit about our data. On our website, we have now several score papers, including about 24 papers from BabySeq. We'd love to invite you to take a look at there. And I'd be happy to respond to any emails of people who might wish to train with us or collaborate with us as we go forward in this. Thank you.
Great, thanks so much, Robert. And now we're going to move into a panel discussion. And I see there's been some questions coming up on Slido. So if we can bring up Slido and make sure all of our speakers, yes, are all visible. One question I had, and I'm going to start with you, Richard, and maybe Robert wants to chime in, is that with some diagnoses and that, we've got the speed of newborn screening as we currently do it, there are some things that are quite time critical in terms of diagnosis in newborn screening. What do you see are the limitations from a time perspective, and as has been put in chat, the challenges when you're doing this at scale? How quickly do we need to do this? So Richard, I'd love your response on that.
I think on one hand, and Zonitsa gave some in her example, an example of where being very rapid is necessary, and you can't be too fast. I think that's one thing. The other thing, as you say, is about feasibility and scalability, sort of at reasonable cost. What we're looking at is matching a sort of similar time scale to what current screening achieves, and sort of a roughly a 2 or so week window is what we're shooting for, and we think that's feasible.
Fantastic. So we'll go through Slido questions, and another question for you, Richard. During the public dialogue and consultation, was there a consensus reached on whether both treatable and untreatable disorders should be included?
I don't think I'd describe it quite as a consensus, because there is a diversity of views, but I think there is generally people are centering around the large majority of people being most comfortable with treatable, sort of severe, early onset treatable disorders, and that's the direction we're going in. As Zornitz's data was interesting, there's definitely people who are interested in thinking more broadly. We're keen to sort of start cautiously and build from there. And I think sort of ongoing discussion during our program and the ongoing sort of dialogue with participants and potential participants will guide us.
And one comment that's come up in the chat has been that importance about distinguishing between what is newborn screening of healthy babies versus the application in newborns of genomic sequencing. And so in the chat, it was really, there was also some work going on that in the Italian study, the Screen for Care study as well, but getting a consensus around the terminology we're using of the application of genomics in newborn, I think, is going to be very important. So that's something that we can work on as a group as well. And Zanitza, just to again comment on that treatable versus untreatable, and where you think that's going from your perspective, because you've been coming at it more from the diagnosis in critically ill infants.
I think for our newborn screening projects, we're keen to stick to just treatable conditions to start with as a toe in the water, but it's certainly very interesting to see the views of parents in those previous pilots. But I guess to bear in mind that those parents already had a sick child, and that's the reason why they were part of those studies, and they had quite a lot of information about genomic testing as a diagnostic test from a genetic professional, so they were quite well informed, which will not necessarily, that won't be the case for newborn screening programs. These will be couples who are expecting a healthy baby and are potentially still in the middle of pregnancy.
So then the question of, and I might open this in terms of the experience of England and also from BabySeq, how long do you envisage the data actually being used for lifetime genomics, given the evolution of sequencing technologies? Richard.
I'm happy to answer. I mean, it's a how long is a piece of string question. Like we've all been here watching Illumina short read technology be the predominant sequencing technology for more than the last 10 years, and you can't. Science comes in jumps, doesn't it? I think we have to recognize that while I think it's important to talk about lifetime storage, because some of the data, even if will remain useful in various ways, I think we also need to recognize that technology does move on, and be sort of transparent about that as we talk to people who join programs. And we've been talking recently about how you explain that to people so as not to give some misleading expectations of always having data that would always be the right data to analyze to answer any given question, but also saying we will look after your data as carefully as we can for as long as it is useful. And I think research uses and clinical uses have different timeframes as well.
So a question I might direct to you, Robert. Can you address how you're considering the issues of equity, because you did mention this for the new study going forward, in terms of public involvement, and the issue I was thinking of when you were talking in terms of our reduced knowledge of variants in minority groups. And I know that's being addressed through all of us as well.
Yeah, that's been a thread through all of us, and all of us, and not the project, but all of us who are in this community of geneticists trying to implement genomic medicine recognize the limitations of the existing databases, of course, and that's been discussed quite a lot. This happens at various levels. It happens at the database level, it happens at the uptake level, it happens with regard to trust in the environment, it happens socioeconomically with people who can afford to pay for products that they're launching in this space in the commercial market. I guess the best case scenario is that, sort of like early cell phones, things that were available to people who could afford them and were clunky, but then came rapidly down in price and then became more universally available. We can hope that access to genomic medicine takes something of the same course. It may be somewhat unavoidable that those who volunteer may not be fully representative. Now, in our BabySeq 2, we have explicitly created stakeholder boards, all sorts of community outreach, sort of a mini effort like the All of Us research program, but just within our groups. We're trying to enroll one of the historically Black colleges and universities as an accessory site. So we're taking some really extraordinary lengths to try to make sure that we can enroll as diverse a population of families as possible. But as everybody knows who does this kind of work, it's a real challenge.
Question from Lena Dolman. That's a welcome, Lena. How lovely to have you on this call. How are your projects defining or evaluating clinical utility? And I might open that up and perhaps ask you to comment, Alessandra, in evaluating the clinical utility of newborn sequencing results, and are using any structured tools for evaluating that. So in your planning, how are you considering that? And then I might get other members of the panel to comment.
Okay, of course, this is a very important issue. In our approach for newborn screening, of course, using gene panel may facilitate, the output analysis. Indeed, we plan to have 2 panels, one small panel for treatable disease only, and a larger panel with about 200 genes for actionable disease. And then, especially for these last, for actionable disease, of course, the clinical utility is something that we will consider in terms of, evaluation. So we have a pipeline, of course, we are still defining the pipeline in terms of variant analysis and how to consider variants any type, because we are, planning to pick up also all copy number variations, not only small mutations by sequencing. But yeah, definitely for gene, very focusing on gene, that might be easier somehow to establish clinical utility of variants and of course clinical validity.
And Robert, you did touch on that in the baby-seq evaluation. Would you like to comment on that question?
Yeah, thanks. I mean, that is, hi, Lena, great to know that you're on. That is the fundamental question, because if it's very valuable, then we don't mind paying for it. So it's a moving target. That's one issue. There are constant treatments being developed and constant clinical trials being opened up. And then secondly, clinical utility, as everyone on this call knows, is more than just treatability. It is also reduction in terms of diagnostic odyssey, the ability to psychologically plan, and the ability to go out through cascade testing into the rest of the family, avoid similar reproductive situations that might also be tragic, and help both children and adults throughout the extended family. So these are logistical questions. They are scientific questions, but they're also logistical questions. If we know that you're carrying a certain mutation, how do we manage that information? That's what's so fascinating about this. And I think it is the fundamental question.
Thank you.
I think having structured tools is going to be really important. We've struggled with how we capture the clinical utility of genomic testing for a long time. We've definitely evolved towards having structured tools, especially as you have a variety of providers that are then looking after the downstream results of being able to consistently capture the downstream effects of the test, and the impact is really important. And certainly some of the work that's been led from Robin Haim's in Canada in terms of providing those structured frameworks is very interesting. And this would be a good area to try and align on how we capture outcomes and how we measure impact.
So again, coupling that with the consistent terminologies and definitions of what we're doing, and then the way that we evaluate outcomes and clinical utility. And also we're going to have to look at that in a longitudinal way as well. It's often a lifetime study. A question to you, Richard, because you're sort of doing this as a pilot within the healthcare system. How do you see that genomic newborn screening might integrate with existing newborn screening? Complementary, replace, other?
I think complementary is the most likely, and I think both certainly we know that for the conditions that are currently screened for, the large majority, the sensitivity of the existing assays will certainly beat what current knowledge bases could offer for through genome sequencing or other genomic technologies. That's that's just a sort of fact of where we are. And obviously the benefit of the genomic approach is it lets you cast the net wider. And as long as you have very good positive predictive value, then it's a great test. And I don't think we should be ashamed that the sensitivity isn't there. It's about complementing it.
Yeah, excellent. So we've actually addressed Amy's question around equity, and the next, I think the question around the impact of genetic screening on current and future access to healthcare, and this is for you, Robert, because I think this is much more of an issue in the US healthcare system, and the also around health insurance, the potential use of this data by health insurance providers. I'd love your comments on that briefly. I'm sure you could talk about it for an hour or so, but very briefly.
I'll keep it short. We've never really been good at communicating the federal protections that are in place in the US from GINA, but as most people know, they are pretty good for employer and health insurance, but they don't cover life insurance. There has been progress on the life insurance front. The state of Florida passed a very strong law about life insurance non-discrimination for genetics. So, and there are several other states copying that. So fingers crossed, we are creating a tapestry, part federal, part state, that will provide reassurance against underwriting, which people understandably fear.
Okay, the next question is, it does relate to that time, and I'm going to come back with this to you, Richard. The turnaround time for blood spot screening is just a few days, and whole genome sequencing, you know, looking at time, quicker is better, but in reality might take longer. What are going to be the implications for follow-up? Because I know that you were actually looking that there were the pipelines for clinical care that could be the follow-on from newborn screening, and workforce implications of that.
I think there's a couple of things I might say. The first thing is we're exploring the right sample type and the right sample approaches and the right sampling time, and we might get a head start on the heel prick test if we test on day 0. So that's one thing that sort of means that things might equal out a bit more. I think the other thing is that, you know, every condition is different, and one of the things that we'll be doing before we go live with any condition in our program is sort of mapping out the full end-to-end and the you know, both thinking about the timing of findings, but also, you know, the various different pathways that one might follow along it. So I don't think there's one right time or one right answer across the board. It's very different, and then as Zornitz's case, you know, gave an example of that. You know, that's not a universal outcome in that condition, but it is, you know, it's an illustration of why faster is almost always better when you're talking about these really severe early onset conditions.
I'm taking this part of the session, Lindsay, just out to 15 minutes past the hour, because we can save some time at the end. The question around where this sits in non-discrimination legislative frameworks, I'm going to leave for the intersection with the regulatory and ethics group, because I think has come up with all of the questions, looking at the regulatory and ethics approaches to this, and having a you know, I think having an international approach that we've discussed is going to be really beneficial for all of us as we navigate this in our various countries. I'll go to the question from Veronica about how the variable phenotypes for apparently the same genotype in a family, or you know, within individuals within families. When you've got, we all know that there can be a huge variability, and I think that's something when you're looking at something in screening and how you interpret that. It was like your comment, I think, Robert, on the supravalvular stenosis. It's good to know about that if it then causes problems later on. But I might get you to comment on that, Zanitza.
I don't know. I'm
nodding your head.
I don't know.
It's a great question.
It's a good question, but I feel I'm also practicing clinical geneticist, so I feel like I have to answer this question almost every day with every family that I see. And there's clearly factors that we don't fully understand that alter the expressivity or penetrance of conditions for the purpose of screening. Obviously, it's going to be very important that we stay on solid ground with pathogenic and likely pathogenic variants, but that's a question that we tackle every day in our day-to-day practice, and that's just the nature of genetics.
And it's the same, I think, also when we're looking at prenatal testing. That's where we don't have a phenotype that we can judge. And I do see the comment. We're going to finish now, but I do acknowledge the comment around hypothyroidism is the one I was particularly thinking about, with the importance of speed in screening and being able to implement therapies early. So a really rich discussion, and thank you, panel, for the presentations. And because we'll be, I think we've already identified a number of areas where having consistent standards around terminologies, around the tools we use for evaluation of clinical utility, and what genes we screen and when, at least getting I don't think there'll ever be consensus, but getting that international expert input, I think, is going to be very useful for all of us as we take our programs further. And I'm now going to hand over to my co-chair, Mark Caulfield, to lead us through the next part of the program. So over to you, Mark.
Thanks very much, Catherine, and thanks to everybody who spoke in that session and the panelists. We're now going to look at intersections with the Global Alliance for Genomic Health. And in particular, we're going to start with the Regulatory and Ethics Work Stream. And I'm going to invite Dr. Yvonne Bombard and Anna Lewis to present their work. Anna is from the Edmund Safra Center for Ethics in Harvard, and Yvonne is from the St. Michael's Hospital. So Yvonne, please take it away.
Thank you, Mark. Yes, thank you very much. Unfortunately, Anna can't join me right now, but I am very pleased to be co-leading some of the work on behalf of RUS with her in the space. I'm an associate professor at the University of Toronto, a scientist at St. Michael's Hospital, and health services researcher in genomics and implementation scientists. Our intent, it was such a wonderful introduction and panel discussion. Clearly, a lot of the threads that Anna and I and others have been talking about are going to be interwoven in our introductory slides that we've presented and prepared today. Our intent is very much to identify collaboratively and collectively with the participants today on an ongoing basis where an international regulatory and ethics lens would be most helpful to advance the development and implementation of some of these pilots. And it's and in doing so, it's important to recognize, thank you, where we've been and where we can go from here. So in 2017, a GA4GH pediatric task team, which was a past work group led by Jan Friedman from the University of British Columbia, published an article outlining 8 recommendations for clinicians, clinical laboratory scientists, and policymakers regarding our current understanding, concerns, and consensus around the use of genomic technologies for population-based newborn screening. The 8 recommendations are here, but they can be summarized and distilled in the following 3 principles. First and foremost, genomic newborn screening should be considered as a supplement to existing newborn screening programs, and that sharing data on allele frequency is crucial and imperative, as is the need to develop and disseminate more data and evidence base on the clinical utility, which we've been talking about, creating standard metrics and developing the database for, as well as cost effectiveness. Now, the Regulatory and Ethics Work Stream to date has been thinking about where they can contribute in this space and collectively advance some of these issues and move forward and develop some frameworks through both internal discussions at the RUS as well as external members that we've been able to discuss to date. But these, of course, are only the beginning. And so some of the points that I'm going to be raising on the slide are only scratching the surface and meant to just scratch the surface and open for discussion. And the intent, again, is to raise awareness, get the community's perspective, and help us prioritize some of these overall issues that we've collected thematically here. So the first conversation that has obviously been illuminated throughout the conversations and panelists already is the issue of how to operationalize consent when, how, by whom, what results need to be returned, what are we going to be screening for in terms of treatable, untreatable, child onset, adult onset, and how and when those results should be returned in order to maximize benefits and value over the lifetime. Given that newborn screening programs operate in the principles of public health ethics, and we are talking largely about research-based sequencing of newborns, how do we interface and how do we trade off and potentially deal with the principles that operate at the public health ethics level with the biomedical research ethics? And frankly, what kind of criteria would we be using? Would Wilson and Jungner, the classic screening criteria, apply when we're talking about whole genome sequencing? And whether we need to be looking at other frameworks. And so possible approaches are to explore the ethical regulatory frameworks that can inform such considerations, explore the full stakeholders' values, see if there's consensus, whether and how there might be consensus on some of these issues in terms of what meets the criteria for what types of conditions and variants that we return, and over the course of the lifetime. The next issue that, of course, the GA4GH has considerable expertise is data sharing, and how might an international lens, a regulatory and ethics lens, be helpful in thinking through the implications, both positive and negative, of how to collect the data, store the data, and then share the data in terms of, very practical questions of, there are variable tapestry of policies and programmatic considerations of how the data will be held, who has access to the data, what data sharing arrangements would need to be in place in order to share, what the obligations for privacy and sharing would involve and entail, questions around age of majority and when a child might access and gain control of their own data, and the implications for various countries and jurisdictions and organizations to work together in order to advance data sharing. And again, this is a particular strength for the GA4GH. So possible approaches in order to advance some of these considerations is to develop best practices for international data governance, data sharing, and collaboration. Of course, a major issue that my lab considers, as well as what has been discussed to date, is how do we balance these benefits that are ever elusive, whether they're medical actionability, clinical utility, personal utility, with some of the costs and health system resource implications. What data would be needed to demonstrate sufficient benefit, and how should these benefits be weighed against potential harms of potential overdiagnosis and subsequent overtreatment, the health system costs and impacts. And here, as we've already talked about, there is a very wide inconsistency of what we consider utility, how that is measured, and how those are going to be captured going forward to then conduct comprehensive cost effectiveness analyses. The other approaches that could be considered in this kind of work group would be to explore the different frameworks, health technology assessment frameworks, and value-based frameworks that would be used to consider these balances of various cost, clinical utility, and cost effectiveness data and health system impacts, and how they might be applicable, if at all, across various jurisdictions. And finally, from an implementation perspective, which is on par with the theme of the forum being an implementation forum, is how would we then potentially scale some of this delivery? And questions of, to what extent, if at all, should newborn screening and genome sequencing be a part and interact with existing newborn screening programs? And how would we meet and marry and implement such a interaction, if at all, if that would be appropriate? And here, clearly, considerations of health service delivery, the infrastructure, the system readiness, the barriers of the facilitators, and how that would interact with existing newborn screening program are some of the conversations to date with the various RUS members and work group members to date. But this is just the beginning, and we very much would value your feedback. And so turning over to Slido, I'd like to ask the audience of the issues that we've shared right now, rather than the outputs, what seems to be the most important issue from your jurisdiction, your vantage point, from your the initiatives that you might be running, so that we can help prioritize the work that we go forward within the regulatory and ethics work stream on this topic. So please, if you can share your thoughts, we would really value your help prioritizing the work we do working forward.
Thanks very much. That's super. Well done. So far we've got consent.
Here we go. Yep.
Yeah.
Okay, great. Consent and return of results, interaction with newborn screening programs to date, data storage and sharing, privacy. Yep. Cost versus benefit, interpretation of results, implementation, outcome measurement, data privacy, return of results, meaningful consent. That's a great qualifier.
Yeah, I agree. So Yvonne, that's been hugely thought-provoking. One question from me is about the point about genomics and discrimination. What do you think we need to do about that? Big question, but we didn't cover it in the last session.
No, we didn't. And I'm very happy to say that the RUSE has a genetic discrimination working group that is currently conducting a Delphi study internationally to identify policy options. And what we can do as the genomic newborn screening work group, and I sit on both of those task groups, is to actually identify what kind of policy would make the most sense and seem the most appropriate through the work that we go forward in the newborn screening context. So that these kinds of suggestions for us to bring our awareness to the priorities at play is very helpful for us as we move forward, and we will certainly be in consultation with the community. And I welcome anyone to reach out to me and others at the RUSE so that we can either collaborate or you can elect some of the priorities of the work that we go forward.
So Yvonne, thanks very much for a fabulous presentation and a thought-provoking Slido. So
I think there's two more Slido questions left, I think. Is that correct, Yvonne?
I believe so.
Yeah, okay.
Okay, so let's move here. Okay, what did we miss? I think that actually we've addressed what we've missed, and individuals are starting to populate that, but certainly as a free test option, if there's any other issues that were not addressed by what I had quickly presented, please introduce them and upvote them now. And again, this is an ongoing conversation. The work that we're going to be doing will be starting actually in the new year. So at this point, this is more of a needs assessment of what the community would like us to prioritize in the work that we move forward with. Trust.
Mm-hmm.
Trust from parents to consent to sequencing their newborn's genome.
That's a big one, actually.
Very fundamental, I'd say. Workforce implementation and training, absolutely. I certainly would advocate for paying close attention to some of our Italian colleagues' approaches to the digital tools that they're developing to deliver scale, timing of consent, and how to operationalize that during pregnancy. Thank you for the suggestion. Types of accommodations required for establishing utility for rare diseases, right? And the thresholds to merit, whether that evidence base has been met. Equitable implementation, interpretation, use of AI, long-term storage and interrogation of the data, access to treatment. That's right, and the management and follow up from these from these pilots, impact of results on other family members. Great.
So which concrete output would be most helpful to you in the field?
Right. So we've just gone through a whole list of issues, but if there was an output, a deliverable, a framework, a particular item that would be seen as the priority from the initiatives to date, what would that be as a tangible piece of work?
Maybe while Slido is Slidoing, it might be good to get comments from our panel members of you know, what their top priority would be. Richard?
I'll stop typing into Slido. But I was just about to type what was in the top one, but so going back to a framework for determining clinical utility so that we're all sort of assessing it in the same way. I think that would be really great.
Sunitza?
That and something a little bit more guidance around consent.
Which
Robert?
particular aspect, Sunitza, on consent?
Definitely about reconsenting later in life, if we're going to keep the data for lifetime benefit.
Thank you.
For me, I think really being disciplined about our use of terminology. I don't think it's, not to pick on this, but I just happened to hear it. You know, I don't think it's a risk of overdiagnosis. I think there is a risk of stratifying children or adults into risk categories that then they do not manifest the condition, but they are still in the risk category. And from a public health point of view, may warrant additional surveillance. So we really have to toggle back and forth between an individual perspective and a public health perspective as we think about this, and try to make ourselves comfortable with the notion that we will be identifying people at increased risk who will never get the disease in question. And we have to be willing to live with that if we think that the benefits and the costs are sufficiently well balanced to live with that.
I agree with that, Robert. I think that's a very important point. And to whether you should look at treatable or untreatable diseases, I think many of us would start with treatable disorders where there's an obvious treatment, many of which are dietary, very few of which are expensive, or vitamins or something simple. But there is an opportunity for these programs to create a platform for us to study new therapies too, and give people opportunities they wouldn't get otherwise. So I think that's been very helpful, and you've got a bunch of parameters, I think, Yvonne, from that to take away. So that's very helpful, and we'll invite you back at our next revisit of this subject to share with us where you got to. Thanks very much for a great talk. So I'm now going to move us on to my colleague Augusta Rendon to tell us about adoption of standards and how they may be relevant to this area. Augusto, please take it away.
Hello, everyone. Thank you very much, Mark. Good to see you. I really thank all of you who have stayed to this techie bit at the end. And what I'll do today is just try to do, as my colleague Yvonne said, just how do some of the existing GA4GH standards may have a role to play as we try to implement some of these projects moving forward. I work at Genomics England. Good. You are controlling the screen. Excellent. Oops. How do I go back? Sorry. Yes. So Catherine presented this slide at the beginning that very much starts with a data donor. In this case would be a family and a baby giving their data. And it very quickly moves through all the way to record, which in this case is having created a result, screening result. And then it enters that whole research ecosystem where many of the GA4GH standards exist. What I want to do is just focus on that initial bit of the circle around the diagnostic path that this data is taking. So let's do that. So I took that path and I divided into, let's call them 4 boxes. Initially, one needs to identify those individuals, consent them, collect some samples from them, relatively easy to understand. Then after some sequencing, there'll be some analysis, say alignment, variant calling, but also interpretation, prioritization, classification of those variants. Then it moves on to generating a report that enters, depending on the type of study, either a health record system or perhaps just part of the existing study. And in some setups, then those data become available for further use, particularly in the case of research, having lifetime genomes and additional longitudinal data. And I've colored those accordingly to different domains and standards that are used. So in the, let's call it the study management at the very beginning, there are data models and standards such as OMOP or CDISC, CDM, and so on. And that's what we're familiar there with. In the blue boxes, that's where GA4GH plays a huge role around how do you manage this type of data, how you store it, how you analyze it, federate it, and discover it. And then finally, in that purple box, the medicine, the electronic health record systems, there are other standards. Quite an important one would be HL7 FHIR, but others are also present. And so what I'll do is I'll tell you about the various standards that already exist within GA4GH or are about to be released and how they play a role. So let's start with that first box on the left, and it has to do with consent. There's an important problem when you start to handle many different studies, all of them with different consents, and where you have people trying to access those data with different access requests for different purposes. And that's where data use ontology comes in. And so as you're setting up consent and what questions, it's also helpful to codify them with data use ontology, such as for general research use or only for nonprofit research and so on and so forth. And that will help you down the line when you want to provide access to those data in a much more automated way. There's good examples of that. For example, here in Europe, the European Phenome Genome Archive has many studies now codified through that simplifies the whole data access committee process. So moving on, we have, what was that? Not sure where I clicked. I did hyperlink all of them, so I'll click somewhere else. There we go. Moving on, there is a set of 3 standards, part of the cloud work stream that I want to highlight here. Those are task execution, workflow execution, and tool registry. And as a motivation behind that is the fact that as we start to do screening, we are going to have to move away from just accepting a genome-wide, say, sensitivity and specificity with a relatively standardized pipeline, depending on what standard alignment variant calling pipelines you run. And we're going to have to do quite a lot of work in calling locuses, specific loci more carefully, the SMN1s of this world, and where just the standard pipelines don't get you there. And each gene is slightly different. They need different mechanisms. So just in this scenario, think about the benefit of being able to internationally collaborate in how we call those different loci, where the effort to try different algorithms is reduced. In our case, for example, of the 300 or so genes that we're planning initially to screen for, there's about 20 really important ones where next-gen vanilla pipelines don't do a good job at calling those genes, and so things like the ability to reuse workflows or containers sounds like a great way forward to advance this field faster. And tool registry is nothing else but a place that we can, out there in the internet, deposit and call those tools and workflows so that we can share them. There's another reason why this is helpful, which is that it provides this standards and the APIs behind it. They provide quite a good modular composable architecture about how we think about the analysis problem, the secondary and tertiary analysis. By that I mean some of the problems we have in newborns, as perhaps Dr. Greene presented before, is quite often they will also come back with a rare disorder, or we would like to enroll them in a more careful, comprehensive clinical genetics type analysis. And the ability to think about pipelines not as a long sausage, but something that you can recall as a set of services seems very helpful. And that's exactly how we are rebuilding our pipelines that were very much just for rare diseases and cancer. Good, moving on. There is, you might have heard of Beacon. Beacon is one of the first things that GA4GH came up with probably 7 years ago. And at the time was very simply the ability to ask, do you have this variant, yes or no? It has evolved dramatically, and now Beacon 2, which is about to be released. And if you're interested in the previous GIF workshop, there was a great presentation by Jordi Rambla about what they've been doing with it. But in summary, it's a much more flexible approach to ask of other repositories with proper authentication, authorization, those sorts of things. Questions about clinical and or phenotypic and genetic data. So I believe that that will become quite important as we try to, for example, establish things like prevalence or perhaps frequency of variants in order to estimate things like positive predictive values as we're developing it, but also when you're reviewing the tests, whether that variant is really something that you can believe. To be seen how it'll depend on how many projects such as the ones that were presented earlier are connected to those Beacon networks, but over time you can see that being very helpful. Also at the intersection between that, let's say analysis, interpretation, and reporting comes the question about how we represent variants. I would say that these types of projects in their implementation into healthcare become really valuable, including things like pharmacogenetics and other types of screening. Additional findings become really valuable where they're deeply integrated into the hospital record systems and don't live uniquely in a PDF that needs to be referred, because these are events that you might want to visit many times, or you have to properly dispatch to different specialties. And so for these to live as a kind of first-class citizen within the hospital record systems makes a lot of sense. So I deliberately placed variant representation, which is another one of the standards from GA4GH, in orange, just to represent that this field is quite, there's quite a lot of standards there. HL7 has the genomics reporting standard that includes things like what is a variant. GA4GH has a much more general version of that. There's of course VCF, so important to keep an eye on that. And then finally, going back to that initial circle, then there are all the other standards from GA4GH. I particularly highlight here some critical ones around managing authentication, authorization, identities, and whether you have access to that. That whole area is quite advanced now, and it solves quite important aspects about how you know who's who and how do you provide access to users easily. So that was quite a summary, and I would like to kind of just conclude with two main points around the things I just said. I think we will benefit from being able to reuse local specific colors and share them. That's a challenge that we need to work on together. There are other, of course, challenges, but that was a motivating one. And then the idea of whether we can, over time, start establishing better ways of assessing how many people do you have with this condition, how many people don't have that condition, to try to establish things like penetrance or frequency and so on with the alleles themselves. So I have 3 quick questions to ask people, and then we'll have some open questions. I'll try this Slido again. So the first one is just to warm up. Have you tried to implement standards? So which? So why don't we give maybe a minute on that if people don't mind, please.
So, okay.
Right. Thank you.
I was slightly worried there, and Augusto, you're going to have a nil return.
No, thank you. Those yes, we're doing.
Here they come now.
Congratulations to the one who's using Duo MRCG West Cram Beacon. That sounds like quite a bit of the stack. Cool. Thank you for those responses. Maybe we can move to the next one, which is for those of you who haven't implemented it or are thinking and not finding it useful, would really appreciate if you can tell us why. So that's it. If you didn't implement them, sorry, misspelled, what challenges did you experience? Sorry, let me just clarify the question. Yes. If you experience them, what challenges you experience? If not, what is stopping you? Just to put it there. Sorry again. So if you have, was it hard? Which standard is for what? That's a good one. If you haven't, why not? So it's
I think you've changed the Slido, Augusto.
Sorry, I'm really struggling with IT here.
Thank you.
There we go. We're there.
Thanks, Lizzie.
Yeah, that works.
Any other challenges experienced in implementation, guys?
I'm going to add one, which is the lack of implementations that are just easy to get off the shelf and get running.
Yeah, that's quite
Good.
important, actually. Should we go to the final one?
One last question,
Uh-huh.
which is, as I mentioned in my slides, there was a set of like motivating challenges or use cases around where a standard might be helpful. Would really appreciate if you guys can share essentially what are other areas or use cases where we might want to create further standards or think about use cases that will mature eventually.
Given that we've had some super presentations on newborns, are there any that occur to you, Augusto, that you might want to see developed out of the discussion this evening? And we've identified some for research ethics, but what about?
One that I've always struggled is the standard, the actual computable standards for reporting. So something has been. Yes, the slide about which standards fit I think we're making available the slide deck anyway, so they will come and they have a helpful click that takes you to the toolkit and the documentation. Cool. Mark, I think in the interest of time, happy if we take some questions and then move on. Thank you very much, everyone.
So thanks, Augusto, that was great. Could we go, Catherine, if you're agreeable, to the panel and just see if there are any standards the panel would like to see developed from this? Would that be a good way forward?
Yes.
Robert, what's your thinking?
Well,
what do we need that we're missing?
I'm not bioinformatics person myself, but I do think it would make sense if there was some sort of standard for how we're going to deal with novel loss of function variants, for example.
Yes.
In a screening context versus a diagnostic context. And I assume we would deal with them very differently. And at what point would we even consider them in a screening context, for example? Things like that. In what kinds of situations would we start using burden testing, if ever, in a screening contest? I know these are just random thoughts that occur to me as I think about the bioinformatics challenges in a screening context.
I think they're good thoughts. Alessandra, anything that would help you in your Europe-wide program?
Well, one important point, for example, is to try to find a standardized reporting method that might be, for all different variant types, and try to have a standard reporting method for all variants. So that would be quite an issue. This is what we normally experience also for genetic testing, not only for newborn screening. And we have so many different types of reports with different details and different, contents somehow. So normally we do like very much to be inspired to for example, quality control for genetic testing. And this might be applied as well for newborn screening genetic testing, for example.
Yeah, they're all good suggestions, actually. I like them. Sonitsa.
I really like your suggestion, Augusto, about exchanging experience about how we make sure we detect some of those harder variants, because there's a few genes of interest near the top of the list, like SMA, DMD, Fragile X, the congenital adrenal hyperplasia. The main gene has a pseudogene that are going to be technically challenging for us, and we need to make sure that we're producing reliable results. So we would be interested to talk more about that.
They're very good suggestions. I like them. Rich, anything you can think of that we need to add into this standard setting process?
I think Augusto spends too long listing and talking to me, so I don't think I've got anything that he hasn't already said.
Yeah, no, I think that's proven to be a pretty comprehensive list, but I think this will be available again online as part of the recording that we have, so you can reflect on it. Augusto, thank you very much for a stimulating session alongside Yvonne. That was excellent. Catherine, we're coming towards the end of our evening together. Well, it's an evening here. It's probably the morning where you are. I just wondered if we should just reflect. I mean, we tackle this particular subject because there are a number of initiatives, as you've heard of this evening, who are actually really beginning to take off. And if we can find a way as a community here, I'll be interested in your view on this, Catherine, to try and anchor this from the GIF forum in standard setting. So, because the issues that you as a community have surfaced this evening in response to stimulating presentations, the panel discussion, and then the GA4GH into action in terms of standard implementation. I think these have highlighted a number of areas which will be important to revisit in GIF, particularly as many of you are in the liftoff position or at least in advanced planning for this. And at the moment, I think we're all grappling with what the right answers are here. But if we put our heads together, we'll solve it as a community. It will also mean that we don't go in twin track or even multiple track approaches to this, because we're learning from as we're going and learning together. So I think it's been a super session this evening. Catherine, have you got any closing remarks you'd like to make?
Yes, yeah, no, I agree. I think it's been incredibly useful as we're all embarking on this journey or at different stages of it. But the sharing of experience and just hearing the different approaches, for one, I think has been great. But I do think the last two presentations from Yvonne and Augusto are really highlighting what we as a global alliance can bring together. It's around consent, approach to data, evaluation, clinical benefits, cost effectiveness, implementing at scale, and then how we're applying standards across all of these different areas, which really then we will take back to the Global Alliance work streams, and I think make this an iterative process. It also struck me, Yvonne, particularly in what you were talking about, that the various programs that are underway or are planned to make sure that they are intersecting with your group as well, because you can test these policies out in and approaches in real time, in real life, in patient cohorts, and then feedback and continue to refine and improve them, which I think is a great way to approach that. I've also been saying to Lindsay, just in terms of capturing the richness of this particular workshop, we will do one of those GIF newsletters providing a summary of this workshop and also circulating video for discussions to all the registrants, but also to the GIF and the Global Alliance community so that we can share that. And then we'll work out a timeline for follow-up in terms of bringing all of this back together. But I think we would also feature a session on this in the plenary of Global Alliance later this year. I'm just going to throw that in, but I think it's this has laid the groundwork for a lot of very rich discussion going forward. So thanks to all of our speakers. I think it's been fantastic. So thank you, everyone. Mark.
Thank you, everybody. It's been a fabulous evening. Well done, all speakers, and well done, team, for suggesting fantastic opportunities to take forward standards through GA4GH. I'll bid you all a good evening or a good day, whichever it is. And
good morning.
Take care, and we'll see you soon. Good morning, even.
Off
Good morning,
to work.
Bye, everybody. Thank you so much.
Bye.
Take care, everybody.
Bye.
All the best.
Bye-bye. Thank you very much.
Thanks, everyone.
Bye.
Bye-bye.
Good night.